Hi, and welcome back. Thanks for checking in. So we are now starting unit number 7 this year in 8th grade math, and the name of this unit is just simply called volume. So if you remember back from years past of your math classes, finding the volume of a solid figure involves using formulas depending on what figure you're looking at and all that sort of thing. So we're definitely taking a turn more towards the geometry side here in this particular unit. So before we get into any of this volume learning, I thought it would be a good idea to just take a step back for a day or maybe two and work on finding the area of circles. So we're actually going to do that today. We're gonna review the formula for how to find the area of a circle. What does area of a circle mean? And then I'm going to let you get some practice at it. So your learning target here is that you will be able to find the area of circles. Now, real quick, your circle, okay? The area would be if you were to take your pen or pencil and shade inside the circle, like so. And that's a two-dimensional figure, right? So it's flat, doesn't have any depth to it. If it had depth to it, then we wouldn't really be finding the area of it, we'd be finding the volume of it. But two-dimensional figures like circles and whatnot, we find the area of them. So it's basically the space inside your two-dimensional shape or your two-dimensional figure. Now there's a formula involved. Area of circles is equal to this formula right here. This is where it's at. Area is equal to pi r squared, which really means pi times the radius squared, which really means pi times the radius again, if you really break it down. Now, oh boy, about this symbol here, about pi. A lot of you probably remember that oftentimes in math class, when we work with pi, we substitute in 3.14. Now, that's usually okay if you really don't have any other options. However, 3.14 is an estimation of pi that's really not super accurate. So my preference as we're doing these problems today is that you have a calculator handy, and if it has a pi button, I would like you to be using that button instead of 3.14. Now, maybe you don't have a calculator that has a pi button. Okay, well then you're going to have to use 3.14 to substitute in for pi, but I'm going to do my examples, and I'm going to read answers to homework as if you're actually using the pi button, which could make your answers slightly different than they would be if you substituted in 3.14. But I'll always be using the pi button on the school calculators, and I'm hoping that you will be doing the same. Keep in mind, there are free scientific notation, or not scientific notation, there are free scientific calculators out there on the internet for use. So if you're watching my video, I'm guessing you have access to the internet, and therefore you could access a free scientific calculator, which would have a pi button on it. All right, so area is the space inside a circle, and it's calculated using the formula pi times radius to the second power. So a quick review of the difference between a radius and a diameter. Here are two circles, right? This guy here on the left is showing a radius of 5 meters. And the guy on the right is showing a diameter of 10. So don't be fooled. If you ever see a circle that's showing a diameter and they're asking you to calculate the area, you better remember that you have to cut that in half. You cut a diameter in half, and that will then equal the radius. All right? And sometimes they'll sneak those in on you, and they're just checking to see if you're really paying attention and being precise and accurate. Okay, so let's do some. Here we go. Get your calculators out, clear them out, fire them up. Area of circles. It's always a good idea to write the formula, so I put it on there for you. Area equals pi r squared. And the directions say calculate the area of each circle. express your answer in terms of pi and in decimal form. Okay, this is very interesting. You're going to need to pay attention as I'm writing the answers to this problem. They want you to show your answers two different ways. And then, of course, it says round your answers to the nearest tenth. And I put a reminder on there that says use the pi button on your calculator. Again, if you don't have one, you can use 3.14, but I'm hoping that you can find or use a scientific calculator. Now, this is the lovely kind of math where I'm going to insist that you show your work. So, for this example, we have a circle. This is the radius. It's 9 centimeters. Awesome. We don't have to cut it in half. Step one is to always write your formula. Yes, every time. Pi r squared. I'm not going to put 3.14. I'm going to use the pi symbol. Times, what's the radius? 9, which I'm going to square. 9 squared is 81. So, if we wanted to write our answer in terms of pi, like the directions tell us to, here's how you would write it. 81 pi centimeters to the second power. Because it was up here, right here, it was 9 times 9, which was really 9 centimeters times 9 centimeters. So that's where we get centimeters to the second power. Anytime we're calculating area, it's always units to the second power. So what I have right now, this answer right here, this is writing our answer in terms of pi. Now it also asked us to write our answer in decimal form. So now is when you're going to use your calculator and you're going to type in 81 times the pi button and you're going to round it. And that is the other correct answer. You absolutely need to have them written both ways. This is writing it in terms of pi, and this is writing it as a decimal, which basically means you just finish the problem on your calculator. So, that's what that means. Let's try some more, now that you've caught on to this, I hope. Doop-de-doo, look at this nice little circle. Oh, this could be a swimming pool. It's 24 feet across. Start with my formula. Pi r squared. Plug in my numbers. What's my radius? Don't you tell me 24. It's not 24. The radius is 12. Oh, see, I hope you were paying attention. Gotta square it. So, here's my answer in terms of pi. 144 pi feet squared. So there's one of my answers. Now on your calculator, you take your 144 times the pi button, round it to the nearest tenth, and hopefully (452.4) feet to the second power. That is your second answer, and yes, you are supposed to have both answers. Let's do another. How should you start? Formula. Pi r squared, pi times, radius is 10, which I'm going to square. Okay, so writing it in terms of pi, it's 100 pi millimeters squared. There's one of them. And if I actually follow through with this now and write it in decimal form using my calculator, rounded, 314.2 millimeters squared, second answer. That's not too bad, right? It's really, truly calculator work. But you got to make sure you're plugging in the radius and you don't accidentally stick a diameter there. Let's look at a couple word problems here. They might have you thinking backwards a little bit. Number 4 says, the area of a pool cover is 500 feet to the second power. So then what would the diameter of that pool be? So they're giving you the area and they're asking you what the diameter would be. We got to work backwards. Just to keep things straight, there's your formula. So what can you plug in at this point? Well, you can plug in the 500 where the A is. That's the area. Equals pi times radius squared. All right, so trying to figure out what the radius is, because once I know the radius, I'll be able to figure out the diameter. So who needs to move away from the radius? That pi. And instead of multiplying by pi, you're going to divide by pi so that it, right, we say it goes away or cancels. So over here, we're going to divide by pi button. And we get 159 equals r squared. Now, we just spent a whole lot of days and weeks working with the Pythagorean theorem. And you should be able to tell me if r squared equals 159, how do I figure out what r is? You take the square root of 159, which is 12.6. That's what the radius is. Great, I know the radius. I am supposed to be figuring out what the diameter is. Well, that means we have to take the radius times 2, because 2 radii make a diameter. So you're going to take your 12.6 times 2, final answer, 25.2, and we're measuring in feet. Final answer. That's your diameter. That means the pool is 25.2 feet from one side to the other. Did you follow all that? It's basically just solving an equation where we're solving for the radius this time. Let's do this one. And this is the last one. A circular garden has a diameter of 15 feet. Well, let me tell you what. I drew that circle there. So if ever you're given a word problem and you think it would help to draw the shape, I would encourage you to do that. So I drew that circle, and if it has a diameter of 15 feet, I'm going to put a 15 feet there. Good idea. The gardener wants to cover it with mulch. Oh, okay, so he wants to fill that area in with mulch, which would be finding the area. Each bag of mulch covers 25 feet squared. Okay, so that's per bag. I wonder how many bags I'm going to need. Oh, and that's what the question says. How many bags of mulch will be needed? All right, so this is kind of two problems, right? We're going to have to calculate the area of the circular garden. And once we know how big the garden is, then we're going to have to figure out how many bags of mulch it's going to take to cover that space. So first, let's find the area. Pi r squared. Pi times, what's the radius? Half of that, right? It's 7.5. I'm going to square that. Actually, you know what? I'm just going to punch that whole thing into my calculator. I'm going to take pi times 7.5 to the second power. Or you could do 7.5 to the second power first and then multiply it times your pi button. Or you could do pi times 7.5 times 7.5. And when you round it, this is the area of the circle. Your garden is 176.7 feet squared. That's the area. But that's not how many bags of mulch I'm going to need. Because each bag of mulch covers 25 of those feet. So I need to take my area of 176.7 and divide it by 25 feet squared. And when you do that math, 176.7 divided by 25, we're going to need 7 bags of mulch. 7 bags of mulch will cover that space. What do you think? Not too bad? Well, keep in mind, this is actually technically a review. This is like something that the unit is already assuming that you have good understanding of this. So Hopefully it wasn't too challenging. And where do we go from here? Well, we're going to carry on into some volume formulas. That'll be the next lesson. All right, so of course, as usual, we will continue to work on this skill of finding the area of circles the next few days of class. All right, take care. See you soon.